How many of you are still with me and you are not lost in the class? So you are not lost in the class. Okay, two of you are not lost in the class. What about others? Do you understand my question? So we pretty much covered all aspects of Unit 1. So I'm asking how many of you are totally lost in the subject and how many of you are still with me, most of it. So if you think you're hanging in there, raise your hand. 2 is not good. 3. 3 is there. Okay, we have 4, 5. Okay. Mohammed and Chetu Paik Lepakalev. If you are lost, let me know you are lost. Then I can do something about it by taking some extra classes or something. Okay? Okay. Good. Good morning, Mr. Rai. Good to see you. Let me ask the same question to JNTV. I think I kind of know their answer. How do I do see show of hands in JNTV. I see them raising hands. That is good. I can't see the video of SVCW or Boliseti Santoshi. So if you can put it in the chat, that would be great. Okay, the students are walking in. So let me go back to normal mode here. I think I'm sharing my PowerPoint. Just before I joined the class, my daughter reminded me what is the code that you are giving today. So I had to quickly go figure out one of my, I have a nice collection of codes, I had to figure one out for you. I thought I'll use Swami Vivekananda. It's really all power is within you. You can do anything and everything. So very great quote. It came. Actually, I believe this quote was given in the context of education, if I am not mistaken. So believe in yourself, and you have the power within you to achieve anything that you want, right? Including you have the power within you to get an A grade in this class if you work hard. As I'm saying this, my kid is laughing in the background. Just to let you know. Okay, great. Exciting topic today. We are formally doing Unit 2. I say formally because some of those concepts we have been covering anyway. But we are bringing a little bit more rigor and formality to Unit 2, where the focus is basically on stacks and queues. Right? So we'll talk about what a stack is, stack operations, how do you represent the stack using arrays, linked lists, things like that. What kind of applications we use stack, we'll look at that. Some interesting examples like reversing a list, factorial. We already did the factorial, right? The same thing. Infix to postfix transformation. We'll in the process we'll learn what infix notation is, what postfix is, and then finally, of course, arithmetic expression evaluation. After we do stacks, we'll get into queues. Same thing, similar format, right? What are the basic operations? How do you represent the queue? Right? So stacks and queues are actually called abstract data types. So I have not introduced you to the definition of abstract data type, but we'll come to that too. Okay, so put on your seat belt and let's go for a nice ride now. Right? And as always, if you have questions, put them in the chat. Get ready to doing some hands-on also in class today, very soon actually. Sheets of paper, pairs of students, and then we'll do the exercises. Okay? Great. What are all these things? Can somebody tell me what do you call them? This is what? On the top left corner. Is it fair to say it's a stack of books? Stack, there you go. It's a stack of books. What is this on the right? The right image with those rings. Good morning, DMF. Any name to the image on the right? Anybody? Of course, if you ask your professor there, it is a toy. First of all, it's a toy, right? Fisher Price toys, right? But it's an interesting toy because in computer programming, I was going to give you this as an assignment. We didn't cover it. What is it? Tower of Hanoi? Heard about Tower of Hanoi? So it's basically a stack. You see from the ring goes from bottom is the largest one and next largest and so on. Okay. Now the trick is to there's a nice programming exercise. Given a Tower of Hanoi here, how do you transfer these things onto another tower like that in the same order? Okay, you're given one stack like this with these rings, and then you're given an empty stack, and the goal is to transfer these things into the empty stack. And the order should be like this. How do you do that? It's a very interesting computer programming problem. Hopefully we'll get to do that here as an exercise. One of these classes, or more like a homework for you. Okay. What is this type of a stack? Can anyone give a name to that? This image where you see data, we kind of covered that in our classes. Faculty members are welcome to answer to for the benefit of all the students. Call stack, perfect. It's a call stack, really, right? What is a call stack? So you have a program. Let's say you're all C programmers, right? So you start where? Main, correct? And from there you're calling functions. When you're calling functions, all the calls, that's the call stack, that's why you call it call stack, right? All the calls there, the activation record is stored on the stack. So the system keeps track of the sequence in which these functions are called. So when the function call is over, it should go back to the caller, right? And by maintaining this activity stack here, you will see that it knows the program and so on. Okay? That's good. 3 out of 4. And what is this on the left side with dark blue colors? What is it that the image is trying to tell you? You cannot hear my audio? So far everyone was able to hear. Can you hear me now? Can you hear me? Yeah. JNTV is able to hear me. Somebody said, okay, loud and clear. Okay. That's nice to know. But somebody was not able to hear. Who was that? Usha Ram College. Usha Ram College send a note to JNTU Kakinada. They will solve your problem. Okay, thank you. So, okay, somebody answered, Jntuk Moocs Ds. They are operations of stack. So as you can see, typically we say what are the basic operations of a stack. You can either push an element onto the stack or you can pop out moving. Okay? The stacks are everywhere. And intuitively, you all know what a stack is. Somebody is talking you. Mute yourself, please. Okay. So intuitively, we all know what a stack is. When you go to a restaurant, do you see the guy, the server, carrying a stack of plates? That is a stack, a stack of trays. So stacks are everywhere. It's so intuitive. Now, your intuition, if you expand the intuition, what you see here is you have an element placed on top of another element. That's what it is, right? A tray placed on top of another tray and so on. So when you have a stack of plates like that, common sense dictates when you're placing another element, do you place it on the top of the stack? Common sense says yes, right? Similarly, when you're placing it, that action is called push. Now, similarly, when you're trying to take elements out of a stack, have you ever tried to a stack of plates? It's kind of hard to do that, and it will be a disaster. So we always take it out from the top of the stack. And taking out is called the pop. Okay? So that is the intuitive way of introducing you to stacks. So now let's get on to a little more formal definition, right? So it is an ordered group of homogeneous items of elements. Okay? You can see there, like all the cafeteria tricks, they're all the same. Stack of pennies, they're all the same. Stack of boxes, they're all the same. Shirts. Of course, if you ask my son, he would create a stack of shirts and pants and everything together. Okay? Don't ask me why he does that, but he does that. Okay? Now, and then elements are added and removed from the top of the stack. I gave you intuitively, that's what we do there. Okay? Now, the fact of adding and removing, if you look at the notice there, whatever was the last element added is the first one to be removed. That means always from the top, right? That was the last element added. That was the first element removed. It's a good exam question for you. If they say give at least 2 or 3 characteristics of stacks, these are the 3 bullet points that would come in handy for you in an exam. So I do see Chaitanya folks sitting in front of computer terminals. So you're actually watching the lecture there on the terminal? Is it being projected there? Chaitanya? That's good. That's fantastic, actually. That means each of the students can actually, hopefully they can chat too in the terminal. Okay. So what are the basic stack operations? Push and pop, we have already seen the image, right? If I want to be too accurate about it, yes, push and pop are the basic one. But since I'm a computer scientist as well, I also use stack top as one of the basic operations. Okay? It doesn't matter. If you just call it push and pop, I'm fine with it. If somebody adds 1 or 2 more operations also, I'm fine with it. But it all begins with pushing something into the stack and popping something out of the stack. Okay? We'll add a few more operations as we go along. Okay. So here is a lot of pictures. Chaitanya, can you mute yourself? I'm muting you here. Okay. I was getting some static. So here are some nice pictures for you. So stack representative is kind of like it builds like this, right? You saw from the image. What did we do here? The stack on the left shows what? 2 elements there, and you can see the top of the stack is shown, some symbol. That's why we always say we use that also as one of the basic operations. So you do a push operation. Okay. So when you push, what are you pushing? You're pushing some data, as you can see here, from the top. what is happening? The data is placed on the top. You can see the grayed out box there, and then the top is always keeping track of where the last element is, right? So now that you pushed, then the top has moved to the element that you pushed. Got it? It's very fairly simple. Concepts are simple until you are asked to program. That is when concepts become a little bit fuzzy, and then after you implement the program correctly, they become 100% clear in your head forever. Okay? Now, that was the push. Remember, and then now the pop. So what does pop do? So you see that created box on the left there, that's where the top is. They're always popping out of popping the last element. You're not popping somewhere middle elements. So you pop the data, that data comes out, and then the top now is decremented by 1 because we removed one element. Top pointer moved here. Easy, right? So far so good. Let's keep moving. If you have any questions, put them in the chat and I'll slow down. Sorry. Okay. So what did I do here? I gave an expanded example of the stack operation. I would not spend too much time on this slide, but it is there for you to review once I post the slides. Empty stack to begin with, step number 1. Right? Then you are pushing data called green. So now you can see green is there and then the top is pointing to green. Step number 2, you are pushing blue. Blue is there, top has moved to point to blue. Step number 3, you popped out of the stack. When you popped out, the blue got popped out, and then you're left with green, top has moved to green. Now you're pushing red. Okay? Then you're pushing, then you asked, instead of asking push and pop, you asked the stack top. What does stack top do conceptually from this picture? You can see that it is basically returning what is there. Returning meaning it's not popping out, it's only returning the value of the element to which top is pointing to. So top is pointing to red, it is returning the value red. Step number 6, you pop, red is popped. Now when you pop one more time, what do you get? You get an empty stack. Got it? Very useful picture for you to review how the stack operations push, pop, and stack top work. Push and pop are easy, you know that. Now where there is a push and pop, to keep track of where to push the element to, you keep track of top. You have a variable called top, which always tells you what is the top location. And then you have this other primitive operation called stack top, which basically returns the value at the location where top is pointing to. Questions, comments? I see Chaitanya, a whole bunch of girls sitting staring at the computer screen. Do you all understand so far? You can just raise your hands. Do you understand what we covered so far? If you do, then raise your hands. If you don't, then raise 2 hands. That tells me you didn't understand. So, if you don't raise your hand and you are very shy, then I don't know whether you understood or you did not understand. So you better give me some positive feedback. Positive meaning whether you understood or you did not understand. I kind of see some hands raised in a shy way. You know, when I say raise hands, I think I'm on video. Now, do you see my hands raised all the way to the top? Like exercise, right? Not like this. Like that. I want you guys to raise your hand like that. Next time I ask you to raise your hands. Okay. Now I'm adding more and more details, okay? So when you push, I added some slight thing called item type new item, because remember, they all have to have some type, homogeneous list of items. Okay? So what does push do? It adds a new item to the top of the stack. By now you already know that. You must be saying, Professor, why are you repeating the same thing? I'm actually repeating the same thing. However, as I'm repeating, I'm adding a couple of more conditions there. So in order for the new item to be added to the stack, what are the pre-conditions? And what are the post-conditions? Pre-condition is before you do the operation, what should be the condition? The condition is stack has been initialized and is not full. Okay? So there should be a stack to begin with for you to add an item, right? Agree? If I have to say something like this, let me make this. If I have to say something like this in my program, if I have to say I equal to 12, right? What is my precondition there? That the variable I has been declared, right? You all agree? If there is no I in the program, if I say I equal to 12, what would happen? It's a question, anyone can answer. If I have a statement in a program called I equal to 12, precondition is I has to be declared first, right? Integer I or whatever, or double can take an integer value, right? And I have not declared it. When I give I equal to 12, what would happen? Any student can answer that. You can put it in the chat. It's a no-brainer question. Come on, you people did C programming. You should know the answer right away. What would happen if I have a statement called I equal to 12 in a program and I has not been declared? Would your program work? Would your program compile? Is my question so stupid that you refuse to answer? I is not declared. It shows error. Thank you. Exactly. So when I write something like that, we write typically computer scientists write pre-condition, post-condition, meaning what should be the state before you execute something and what is the state after you execute. So here, in the case of I equal to 12, my precondition is I should be declared. What is my post-condition? Post-condition is I should have the value 12. That's it. So if I want to figure out, hey, if I equal to 12 is correct or not, how do you check the post-condition that I has 12? Simple printf statement, right? Got it? So, going back to push, we are saying the stack has to be there. That's what we mean by initialize. Just like how we initialize the variable I, here it is saying that the stack has to be initialized. Very similar concept. Okay. ABRCT is saying my voice is not clear, but there are others here who are saying my voice is loud and clear. So if majority of them are able to hear me well, then it's an isolated problem. You contact Jntuk Kakinada. As you know, I think they gave you numbers and all that. They will solve your audio problem. If all of you are not able to hear me, then it is my problem. Hopefully it will get better. Check your audio settings. Typically in WebEx, when you go, there's an audio on the top. You see audio. Click on audio. It says computer audio settings. Check those computer audio settings, if they're set correctly or not. Okay. Okay. Going back to this. So precondition stack has to be initialized, and it should not be full. Okay. So some new concept has come there for you. Because so far we have not declared how is stacked, how do you check whether it's full or empty. We don't know that yet. These are the type of things that we are going to learn as we go along. Okay. Post condition, the new item is at the top of the stack. That's easy to verify, right? Whether it's the top item. If I'm pushing 12 onto the stack, it's very easy to use the primitive function called, whatever the function we call is stack top. And stack top is a generic word that I gave you. We will define our own function name for that. Okay, to figure out whether that value got pushed properly or not. Okay. ABRCT, if your problem still persists, please do let me know. Okay. What does pop do? We already know that from the visual that we saw. It removes the top item from the stack. Okay? Now what is the precondition? Same thing again. Stack has been initialized and is not empty. Right? Can you pop from an empty stack? If there is nothing in the stack, what is there to pop? Okay? And then when you pop it out, typically you assign it to a variable. That's why you see the post condition. Think top element has been removed from the stack, and item is a copy of the removed element. Meaning he's saying something like item equal to pop from stack. Okay? So it's a good idea. I do not know if you have learned these concepts called preconditions and post conditions in any of your computer science classes in first year or in second year, first semester that you're doing right now. Fantastic idea to think about preconditions and post conditions whenever you're writing functions, not just in this class, not in C programming class. Everything that you do in real life, you are all going to be programmers, right? Whenever you write a function or a procedure, first thing you have to write is what are the preconditions. Meaning what should be the status of mind. It's kind of like, it's very simple, right? Conceptually, it's a very simple idea, right? You want to go watch Kabali movie, okay? 6 o'clock show today. What is the precondition for that? What are the preconditions for that? Your function this evening at 6 p.m. in Kakinada or Vijayanagaram is to go watch Kabali. What is the precondition for that? Anyone can put it in the chat. It will be interesting. You will see different answers coming for that. The question might sound silly to you, but you will see in the chat if 3 or 4 people put answers, chances are I will see different preconditions. So let's play that game. Okay, Jntuk Kakinada said book tickets. Okay, what are the preconditions? If you're a faculty member, a male faculty member will say, wife has to agree. If you're married. Is that a precondition? In my house, whenever I have to go to a movie, I have 5 people to let they have to agree before I can go. Of course, you should have money. That could be a precondition, right? So many different preconditions. So the idea, the general idea is, you should get into the habit of writing preconditions whenever you are writing programming, whenever you are doing programming. When you get into the habit of writing preconditions and post conditions, you would become an exceptionally good programmer. I can guarantee you that. Okay? Okay, good. I got only one answer, but I'm moving on because there are a lot of material to cover. Here is another tutorial representation which I'm going to skip, but it is there for you to see how, if you have to trace it, what is happening here, right? When you do stack.push 2, 2 is on the top is pointing 2. Then you're doing a push 3, push 5, pop, 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 and push again. So you can see how to build a stack. Stack is nothing. You see how you're showing a one-column table there, right? So you can trace it. This is a way of tracing it. Okay? Okay. Same thing again, continuing. It's all about stacks today, right? Different way of saying it about stacks is the axis is around only at one point of the structure. Right? I do not know how your exams are given there. If they're giving multiple choice answers, whoever created your test could give that bullet point. You'll say axis is around only at one point of the structure. He might stop the sentence right there and say whether it's true or false. The answer is true. Right? If you see, when you're pushing your axis is only at one place. Pretty neat, huh? And it's quite easy to remember too. And the number of operations in stack is limited. We have already seen push and pop. I also told you about top. Okay. You can add a couple of others. As a typical computer programmer, there are other things like, do you want to check? Remember, you cannot push an element onto stack if the stack is full, right? So that's why you want to check if it is empty. Same thing, pop. When you pop, you cannot pop out of an empty stack. So you add some helper functions like is empty, is full, and things like that to do the basic operations called push and pop. Okay? And of course, as we have learned already, it's a last in first out. Whatever is the last element that got pushed is the one that gets popped up. Okay? Good. We're doing good so far. Okay. Time for an exercise for you and time for a cup of tea for me. Right? So, I don't have an answer, by the way, guys. You have to guess these things, okay? So you know how to trace groups of two, simple stack exercise. By the way, I'll introduce two exercises, I think. I think there's one right after this. Let me introduce both and then we'll continue, okay? So in the first exercise, we are saying assume a simple stack for integers. So the first statement should be a no-brainer for you. You are a C programmer. You know what it does, right? What are you doing? You're declaring a stack as equal to new stack. It's kind of like pseudocode, okay? Don't think of it as pure programming code, okay? So you're basically declaring S as a stack, and then you got some memory allocated. New means memory allocated, right? Keep memory. And then onto the stack, you're pushing 12, you're pushing 4. And third one, you're doing something more. S dot push, right? Something got S dot top plus 2, parenthesis. You know the rules of operation, right? Basic operations, things in parentheses are done first and things like that. And then you do a pop and then you do another push in parentheses dot top. So what are the contents of the stack is the question. Okay? That is one exercise. Am I getting the second exercise? Yeah. Okay. Now, okay. By the way, don't put the answers right away, please. Hold on to your thought. If you put the answers, you can put them in private. Okay. Now, once you get your brain cycles working on stacks, now imagine whatever numbers you put. Can you write some kind of a procedure? Pseudocode, not formal C code. I mean, if you're a rich kid in C, you can write. How do you print out the contents of the stack in reverse order? How would you, so you're putting these things, but I want you to print them out in the reverse order. So I'm giving 10 to 15 minutes here. Nice hands-on exercises today. Where instead of listening to lecture and falling asleep, you're doing work. Right? Remember I told you in my class that's what you do most of the time. Okay. Everyone understands the two questions? Is there anyone who does not understand any of these questions? Okay. So I'll leave the slide here because the next one you already know. You should figure out how to print them in the reverse order. Use any of the concepts that you have learned so far in the class. I'm giving you a hint also. You can use some concepts that you have learned in the class. Okay? Now, people who get the code right, any pair of students who get the code right, I will have your faculty member give you a nice lunch coupon for 100 rupees. Okay? That's the deal. Remember, you have to print them in reverse order. By the way, don't put the answers right away. I want students to think, please. Okay? Ready, set, go. So total about 15 minutes for the two things. Once you finish the first one, put the answers there. In private. Okay. I'm silent here because since you're doing the work. If your video is on, instructors please facilitate, professors please facilitate the exercise in your classrooms. And I'll pause myself for a minute to get my cup of tea here. I'm muting myself for a couple of minutes. And put your answers in the chat in private mode. Once I see 3-4 answers on both the exercises, then we'll move on. Time now is 11:06. 11:20 we should be done with these exercises. So 11:20 means that I don't know what your time is there. 11:06. Yeah, 15 minutes. 11:20 and 11:50. By 11:50 your time. So Jntuk, your algorithm, since you put it for everyone, until stack is empty, recursively pop and print doesn't work. Reverse order, what I mean by reverse order is, the stack has all the elements, so you're printing from the bottom to the top. That's what I mean by reverse order. If it was that simple, I would have given you only 3 minutes. Okay, I'm muting myself now. How are we doing so far? Anyone has an answer? I thought first exercise you can put the answer right away. I know AB or CET put, let's see. Jntuk Kakinada put 4, 4, 12, 4, 4, 12, 4, 4, 12. 4, 4, 12. Allow me. Okay, push 12. Okay, 12 is the bottom. Okay, 4. Do you want to verify? Are you putting after the push or after the pop? Oh, after you took away the contents of it. Okay, I see what you're saying. Okay, got it. Okay, pop 6. Got it. Yeah. The second is okay. I have 4, 4, 12 after the pop. Okay. Jntuk Kakinada put also 4, same answer I think. ABR CET did the same thing. Jntuk Kakinada 4, same thing. That's good. So 3 of you got it correct. That's good. Since 3 of you got it correct, I assume it is correct, right? Because I don't verify. I'm just joking. So what was the S dot push dot? The S dot top was really what? 4. So 4 plus 2, 6. So you probably push 6, correct? In the third statement. And then you popped out 6. Then you put another 4. That's why you got 4, 4, 12. Okay, good. And you finished the second part? I want nice algorithm there, not just one sentence. Unless that one. I mean, you can write one line of code which covers the entire program in C, I know that. But having said that, some good explanation of. I'll move to the next page here. If anyone has a good explanation of this procedure, and they are willing to show it on the screen, I can make them the presenter. Somebody wants to present the solution for that? If they're by showing some steps, please let me know in the chat. I will make you the presenter and you can present. Faculty members, you can give me some indication here since I can't see all the videos. They are still working or they are done, they are halfway through, or if people have done. Give me some general idea how your class is tackling this particular procedure. I just call it procedure, a generic term. You can call it function, you can call it method if you're a C++ guy, whatever you want to call it, some algorithm there. So imagine you have 4, 4, 12 in the stack and you want to print them out. The order should be, actually the 4, 4, 12, for example, you can just take 6, 4, 12. The order in which you print them would be 12, 4, and 6. That's what I mean by that stack operation. And the hint that I gave you can use the things that we have learned in the class. So far, not in today's class, you have an idea. And then what do you do? But you still have to print, right? There you go. Okay, that sounds good. That is one way of doing it.
Okay, sir. Basic.
Any other ways of doing it? Let me give you a hint. What if I say the stack is of some fixed size? Let's assume stack is of size, let's say, for the sake of argument, I'll call it 5. You know the size of the stack already. Let me put that additional parameter there.
Specific data content.
Not every college will have come with the same idea, right? So if you know the size of the stack, would your algorithm change in some way, or will you still do the same thing? I see SVCW active, small SVCW competition here. The girls in SVCW complete the assignment. Raise your hand, as you can see. Oh, I just lost your video. I see Pragati there now. Did anyone else come up with a different algorithm to do that? Creating another stack, moving them there and printing there, and that solution is already over. JNTU, we won that. Who else has another solution which is different from theirs? Is what I'm trying to arrive at. Draw pictures. When you're doing these things, draw pictures. I'll give you a hint. There's another data structure which I have learned which can be used to do this. With the assumption that I told you the size of the stack is known. Okay, somebody put something. Let me read that. It's okay to put for everyone now. I gave you enough time, right? Okay, we should first specify the stack size. Okay, understood. Then we should take specific data and push it into the stack. Increment top value. That is also good. Then we should print the corresponding top element by popping and decrementing the top. But then you are printing in the same order in which you push, right? Last in, first out. But what I'm saying is, let's say you're pushing. I see Jntuk Kakinada, I'm putting your answer for everyone, so that way they know what I'm talking about. So let's say I'm pushing 12, 4, and 6. So I push 12 first, second I push 4, then I put 6. Okay, that means my stack would look like 6, 4, 12. 12 being at the bottom. Right? I'm saying you print it out in the reverse order. Reverse meaning not 6, 4, 12, but I'm saying you should print 12, 4, 6. But what you have written there seems to be you will print it as 6, 4, and 12. If I'm reading your sentence right, I'm reading it like you are going to print it as 6, 4, 12. I'm saying print it as 12, 4, and 6. Unless I read your statement wrong. You can correct me if I read it wrong. Anyone else? SVCW? You came up with some algorithm? Or Pragati? Good morning, Pragati, or Usha Rama. SVCW, I do see your video. If you have come with something, put something up there, your procedure. By the way, these are all fairly simple problems. Huh? Just making you think, that's all. Okay? Let me, in the interest of time, did anyone use array to print them in reverse order or something? Do you think an array can work? You're given a stack. Of course, stack itself needs to be implemented in some way. If you, correct, it can be used, right? So as you pop the elements in an array, so what if I write like this, something like this? Let me write it here, okay? So I go here. So let's say I have an array. I'm saying some size, right? I'm just giving you a hard-coded one. Let's say I say array 4. Okay? So as a pop, if I say A0, so you can say A of 0 gets pop, right? Pop from the array. Like that, right? There are 3 elements, and then I'm saying that, so this is the top, right? When you are popping, the pop function would always get value top, right? And then that gets pushed there. So if I have element 6, 4, and 12, so array 0 would get 6. Okay, then I go to A1. I do the same thing. A is small a. Please take it as small a. I don't want this autocorrect, then that causes a problem. If I do pop again from the stack, I mean, you'll obviously say s dot pop, right? Because you have declared a stack. I'm not showing all the pushes here. So here it would have put 4. And A2 to get s dot pop, and here you have gotten 12. Now you have to do a for loop, right? Now when you do for loop, what is the trick here for I equal to, I mean in this case 0, 1 to 3 element array. I'm only showing you 3 elements, let's call it 3 here. So you say for I equal to 2, right? I less than or equal to 0. Less than equal to 0. What do we say? We do I minus minus. Typically we are in the habit of writing I plus plus, right? We go from left to right. We go from the lower index to the higher index. If we want it in reverse order, we go from the higher index to the lower order. That's one way, right? I'm just hard coding a few snippets of code, not the full code there. You need to declare your stack, you need to do your push, all of those things. See that? So, you got it? Anyone have any questions on that? Then you do a for I equal to 1, then you say printf, right? Printf, you know the code for printf and all that. I'll leave it there. Why should it be greater than AI? I equal to I. That's, sorry. My mistake is greater than. Thank you. Thank you for that. Yeah, it cannot be less than. Greater than. Yeah, I minus minus. There you go. So you're paying attention. I'm glad. Thank you for correcting that. So that's it, right? So you can see how anything that we learn, we make use. What I call all these things are like a toolkit for us. Sometimes we use arrays, sometimes we use linked lists, sometimes we use some of the data structure. But there are a variety of ways of doing that. Now, and as we talked earlier, when there are a variety of ways of doing that, the trick is to choose the right data structure for the right algorithm. When you have those two done correctly, then your time complexity would be less. Now, you chose array here because you knew the stack size. If you did not know the stack size, can you use an array? Let me ask you that question. If you do not know the stack size, can you use an array to do it? Probably not, right? Unless you take a chance. Because array dimensions are always fixed. When I do not know what my stack size is, how can I use an array in the example with a fixed size, right? So sometimes it may work, sometimes it won't work. Okay, good. Let's see what this one is. Some of these things, by the way, I have not worked out before coming to the class. I just put them there. So you help me solve the problem, okay? The collective wisdom is much stronger than individual wisdom. So there's some kind of a stack error here. Let's see what it is doing. So first line says you have a stack S that you declare. New means you're allocating memory, remember? And then you're saying for integer I equal to 0, I less than 5, I plus plus, you're pushing S dot push. Okay? So you're pushing what? 0, 1, 2, 3, 4, 5. Then you're printing out the contents of the stack while emptying it, right? Meaning you're popping it out. For int I equal to 0, I less than S dot size, I plus plus. System dot out dot print, meaning you're printing. You're printing and then you're also giving the quotes. So what is the error here? Do you see any error here? I think it also gives you what is the output. I think in the next slide. So what is the right answer for that? A, B, C, D, E is what it's asking. Basically, you pushed I 0 to 4, basically 5 times, right? 0, 1, 2, 3, 4. So it should be 4, 3, 2, 1, 0, you would think. Okay? Correct? Common. When I look at it quickly, without saying what is common stack error, why do you get a... The only error I see is it's a runtime stack, right? Are you going to get a runtime error because are you trying to pop out of an empty stack? Think about it. Remember, when you're trying to pop out of an empty stack, it's an error. Similarly, when you're pushing into a full stack, it's an error. You cannot push elements into a full stack. So I think here, because of some boundary condition, I think it's going to give you a runtime error. If there's no runtime error, then you obviously print the contents as since you're popping from the top, right? So first you're putting 0 at the bottom. 0, 1, 2, 3, 4. So you print it as 4, 3, 2, 1, 0. So I think because of the boundary condition here, I did not trace it. But that is the error, I think. That will be a runtime error. Somebody can quickly trace it and tell me and put it in the chat, that will be great. There will be no output. I think the correct answer here is E. No output due to runtime error. Okay? See this one? We corrected that. How did we correct that? What we are showing here basically is how to make you better programmers. If you follow the lesson carefully, that is what is happening here. Even though it's just a data structures class, along the way, as I told you, programming and data structures go together. In the process, we are teaching you good programming principles. So here is a corrected version of that stack. And what did he correct really? If you really look at it, he put a less than. Other thing was, I think there's a limit. He declared a limit called the size of the stack. He got the size of the stack, and then he's doing it for less than the size of the stack. Okay, that is one way of doing it. Other way of doing it, use the function called, hey, while stack not empty. That's what not s dot is empty. So there's usually a function which keeps track of the top of the element, and it also keeps track of the bottom of the stack if there is no element to take. So by putting either of these conditions, you would ensure that your pop would not result in a runtime error. Okay. So hopefully these examples would give you some insight as to how to write code as well. And as always, whatever we are learning, I want you to execute them in your C programming class, right? And then put them out, your solutions in the community. Okay. So, we have learned what a stack is, and we have learned what the basic operations are. Now, how do you represent a stack? In your C programming language, do you have anything in the syntax called a stack? Can you say just like integer I, can you say stack s in C programming? Is there any programming language where you can say stack s to your knowledge? No, right? So, now what that means is you have to somehow figure out, this is a concept, right? So the stack is a concept. Concept meaning a term that computer scientists use, it's called an abstract concept. Okay, we use it for our modeling purposes. Whenever you are abstracting something, you are creating some conceptual model which would allow you to discuss various aspects of the problem at a higher level of thinking instead of thinking in terms of the computer language. Okay, that's why I say stack is an abstract data type. I'm going to talk to you about what we mean by an abstract data type. Okay. Same thing with queue. In the programming language, you do not have a syntax called queue type like integer type, and say Q1. So Q1 is a variable of type Q. That's also an abstract concept. So when you want to implement an abstract concept or represent that abstract concept, okay, you need to have some underlying primitive data type which is provided by the language that you can use to implement that, to simulate that. I showed you that example when you did the next exercise, right? I said, if you know the size, you could use an array, concept of an array, to do the reverse, right? Slightly, I introduced the concept slightly there. But this is what we do typically as programmers. There are two basic choices that we have to implement a stack. One is an array, one is a linked list. Okay? So, we know arrays. Did we learn linked lists before? We did, right? We learned linked lists which are single linked lists or double linked lists. Okay? So we can use these two primitive data structures, as we call them, as opposed to the abstract data types or abstract data structures, to implement the concepts. Okay? Let's look at that. So, now, I'm not sure in your syllabus, I'm assuming that syllabus implies both linked list implementation as well as array implementation. Okay. For the purpose of today's class, we will look at stack, which is implemented using the linked list concepts. Okay. Pay close attention to these slides. You would not, I can guarantee you would not understand it completely by the end of the class. However, I can guarantee you that you will understand it completely when you implement this after the class is over as a homework assignment. Fair enough? You learn by doing, not by just listening, right? Okay. So, to begin with, on the left, figure A shows you the conceptual stack, which we are already familiar with now, right? That's what I've been beating so far. And then, if you notice, I always write my top here because that's how we keep track of it. What do you see when by the time it came to implementation? What are you seeing here? You're seeing in nodes. Each of them are nodes, correct? And does the node look like a linked list to you? Remember linked list, you declared linked list as a struct. Remember? Struct, linked list, you had a data value and then you had a pointer to the next node. That is what this is showing. Physically, when you have a linked list, you are basically putting them in each of the nodes and then manipulating the pointers to point to the next node. That is what you're doing. So you have 1, 2, 3, 4, 5 elements here, right? So 1, 2, 3, 4, 5 nodes, and the head is pointing to the whatever is the top element. So far, so good? Okay, now let me go to the next slide. Okay. So in this particular case, he is visual. You keep track of the count. In one of the chats here, one university, I don't know which one, if I look at the chat again, I can tell you, so they will keep track of the count of the elements of the stack. So you have this count in top. Again, we are not writing in a programming language yet. It's still pseudocode, right? And then you have the nodes themselves, which have the data and the link to the next node. They are keeping track of count and the top. And then the actual data nodes have the data that you can see stack node structure, right? And then the link to the next one. For the head, to keep track of the head, where the head is, we created a separate node by itself, where you are keeping track of the count and the top. Head is nothing but the top, right? In the case of linked list, we call it head, because that points to the first element. Okay? Here is a beautiful graphic representation of how that is built. You have like the Fair and Lovely advertisement, right? Before picture and after picture. Before Fair and Lovely, Kajol was looking one way, and after Fair and Lovely, she was looking another way. As you know that. When she first came to the movie, she was pretty dark. That was the before picture. After she became a brand ambassador for Fair and Lovely, after 2 years, she became one of the fairest people there in Bollywood. That's after picture. Similarly here also, before picture, after picture. So before, no stack. Everything is empty. The universe is empty. Okay? What is the first thing that you need to do to put something into stack? First you need to acquire a node. That's what this guy did. The moment you acquire node, but you did not push anything, top is null because there is no, it is an empty stack. You have not pushed anything. So the count is 0. Okay? So you can see the picture of the stack here. So you start from 0 and in the second row, you have an empty stack. Now all of a sudden you got another node. And what is the data there? The value green. Okay? So top should point to green. You can see the arrow going there. Count is 1 because you now have one element in the stack. And where remember if you go back to the previous slide here, the data node has a link, right? So when you put the first element there, the link could point to nothing, right? So that's the reason why you see link equal to null. That cross sign symbolizes null. Give me a second. Now when you push, so now you go to the third row. So you have green, one element, count is 1. Now you are pushing the next element blue. So that means count now goes to 2. The top is pointing to blue. Now if you look at the blue link, that link is pointing to the green, and green is pointing nowhere in this case because it's a stack. Okay? Like that you build it to the next 2 rows. Next one is what actually pop. So you have blue and green. Now you are popping So when you pop, what is happening? This is the before picture, and after you pop, the blue is gone, green remains, count got decremented by 1. Now top is again pointing to green. You pop again, then you have no stack. It becomes empty. Okay? So, again, you have to, easy for me to say it in a lecture. You will really understand it once you take a piece of paper and work out yourself like that. Pretty much everything that I'm covering, I'm showing you traces like that. By now you know that. Okay? So when you're reviewing, review the traces. So how would an algorithm look like to create a stack? Remember at the beginning of the class I talked about preconditions and post-conditions? See how that is being used here. Okay? So this algorithm is to create a stack. He has written comments. It says it creates and initializes a metadata structure. Okay? What is a precondition? There is nothing because it's all empty. Post-condition, we've created that structure and initialized it. And there are 2 post-conditions. And then you're returning the stack head. Remember, head is nothing but the top. Since we are implementing a linked list, there is the linked list concept called head and tail. That's why you call it head. Now, to get that linked list, first you have to allocate memory, step number 1. You set counter to 0, set top to null, and you are returning the stack head wherever that is pointing in memory. That's exactly what you have done in this thing here. See, you set the counter to 0, you set top to the empty stack, and return the address of that wherever it's located in memory. Okay, that is create stack. That means the initialization part. Now, once you have initialized, now you are pushing. Did I miss one slide there somewhere? Now you are pushing the elements. So when you push the element, right? So you can see when you're pushing red, red seems to be the topmost element, right? Underneath that you have blue and green, so that's why the count is 3. After pushing red, and you see all the links forming, how will it look like in code? That's what we need to see. Okay, so here is a push. Again, high-level algorithm. This is not C code yet. We'll come to the C code in a second. So when you're pushing when you're calling the function push stack, what are you passing? You're passing a reference variable to the stack. Okay, and then you're passing the data that needs to be pushed. Okay, so you're basically doing push one item into stack, and the precondition is you're passing the stack because you're still the function A and sending you the stack. And here is the data that needs to be pushed. Okay, what is the post condition? The data has been pushed to the stack. Now, whenever you need to push, that means you need to allocate memory. That's why you call it allocate new node in step number 1. You store the data in the new node, whatever data has been passed. Now, make current top node the second node because you just pushed that node, right? It's second this time, third next time, fourth next time, and so on. And then you make new node at the top. And then you increment the stack count because since you pushed, the count should go up. Again, understand the basic concept. You don't need to memorize any of these things. Okay? Goes back to what I told at the beginning of the class. Push means you're pushing and the top keeps moving. The pointer I showed you in the animation, how the top keeps moving whenever you push or pop. Pop, very similar, right? You're popping 3 before picture, and that basically means instead of red pointing to blue, now the top has moved, right? Top has moved to 2, and now top points to blue because red is no longer there. Right? Whatever the top pointer is pointing to, it now should point to blue. Okay? Now you see the thing here, empty box, recycling. What that basically means is it's like you're deallocating the memory. Okay? From the heap, you're giving that space back to the operating system in a sense. So here is a algorithm for popping out of the stack. We'll actually see C code, okay? Hang in there. I'm just giving you a high-level picture right now. What is the precondition? You're passing the stack and you're passing the data. Post condition, whatever algorithm program code called the pop function would get the data. That is the return. Now notice one thing here. You're returning true if successful, meaning you're able to pop. And you return false if there's an underflow. Underflow meaning you're trying to pop out of an empty stack. That is what you're checking your code. See, when I write the pre and post conditions, right? If I'm the architect, when I write that, the guy who's coding it, he knows exactly what checks he needs to perform when he writes the code. That is the beauty of writing pre conditions and post conditions. He can verify that those conditions are true when they write the code. So you see the corresponding thing there in line number 1. If stack is empty, then you are setting some variable called success to false. That means, hey, what does the calling program know? Oh my God, I tried to pop out of an empty stack. That's what that message is in essence. Okay, you put some user-friendly message like that. Else, meaning stack is not empty. So you are getting the data. You are making the other node the top node. You are decrementing the stack count. Remember, for pop, the stack count goes down, and for push, the stack count goes up. And set success equal to true. And then you return the success. Whatever the value it is, the calling program would know it is true. That means it will go check the data value and it will add the values in the stack. Now, if I make you write this in a class on the fly, it will be a little bit challenging. That's why I gave all the code there, or the algorithm at least. Okay. Now remember the other basic operation I said, stack top. You know, a lot of times they only talk about push and pop. Stack top is almost like a basic operation. Okay. Same, following the same lines here, we have preconditions and post conditions. And then the algorithm there, see if stack is empty, you set it to false. Otherwise, set the data out, meaning there's some variable which you're passing to the caller. You take the top, wherever top is pointing, you send the data there and set the success equal to true. Very simple algorithm, right? There's it's a no-brainer pretty much, once you understand the concept. Okay. Now, how do you check whether it's an empty stack or not? If the stack count is 0, it is empty. So whenever you're trying to pop out of it, all you have to do is check for stack count. If the stack count is 0, you say, hey, you can't pop out of it. Got it? Okay. You can also check. This is an interesting one. I'll leave you with some food for thought today on this. How do you check whether it's full stack or not? We are assuming the stack, since the list, you are getting memory dynamically. That means you do malloc. You know malloc, right? M-A-L-L-O-C, malloc. It gets you a chunk of memory equivalent to the data type. Okay? There's some casting and all that you do in C programming to get the right size of memory. Whenever you're doing a dynamic memory allocation, you always put a variable on the left of it and say new of that, and then check the value of the variable. Because if the system is not able to allocate memory, it's going to send you an error code, -1. So then you check the value. If that value equal to -1, then that means memory was not available. It was not able to allocate memory. So it's going to say, hey, it's failed. Okay. Generally, it allocates memory. When it didn't allocate memory means there is no more room to allocate. At some point, the memory will run out, right? They're all finite. They're not infinite. There is a way of counting. See, now you can see how many different functions you can add to the stack. Okay? Return the number of elements currently in stack. Okay, very simple. Since you're keeping track of count, all you have to do is return the count. Okay? Finally, when you're done with everything, you want to, we call it garbage collection basically in C++ and Java and all that. You want to return all the nodes back once you're done with the stack. Okay? So that's what is called destroy stack. Okay? So you're deleting everything slowly. Okay, that's what it is. Okay. I'll continue because I basically want you to basically execute this code. So I'll show you this code for today. We have 7 minutes. There's no way I can cover all these slides here, but I'll let you show you, and then you play with it, and I'll continue this one in the next class. Okay? But let's do something in a community where we can discuss this language implementation of the stack using linked list. Okay? That's how it looks like. You know this picture. You have a stack, you insert. Insert data means you're pushing, and printing means basically you're popping and printing. Okay? Don't worry if the print is too small here, but what it basically shows is a simple stack application program, which is going to show you the basic operation of the stack push and pop. So what did you do here? Line number 11 and 12. Look at line number 11, 12, 13, 14, 15, 16. You use your typedef struct node. Remember, this is the struct definition, right? And typedef basically acts as your alias when you're declaring variables. So since it's a linked list has two things there, right? One is the data, and the other one is a pointer to the same thing, recursive. Remember, we talked about recursion. It's a pointer to the type struct node. So that node star is a pointer. It's a link to that struct node. And then 18, 19, 20, and 21 and 22, they're called your prototype declarations, forward declarations, remember? That way the compiler, if you don't do these declarations here and start compiling code, and then your procedures are somewhere else, the code will not compile. To resolve that issue, we do forward declarations like this. These are called function prototypes. That's how compiler would know, as I'm reading the code, these things are going to come somewhere. So you're telling the compiler, hey, these things are part of the program, so don't flag it as an error. By the way, if any faculty members are there who are compiler experts in this class, don't pick up an argument with me. I'm keeping it simple for now. Okay? Okay, now we get into integer main void. Line number 27 is where you're declaring your stack finally. Right? You're saying p stack top. Whatever variable. For all you know, you can call it variable ABC, you know. But generally you give meaningful names to the variables. Okay? So it is of the type stack node because that's what you declared here, right? Typedef. And then you're basically first thing you're doing there is you're initializing p stack top to null, meaning it is not pointing to anything. Remember, you need to have a variable top to keep track. Okay? Then you're calling the function insert data. And when you're inserting data, remember you always have to pass the pointer to the top wherever, because initially it is null. There is nothing there, right? Okay? That is the main. Then what happens on the next slide? You're inserting the data. If you're inserting the data, you have your own procedure. Again, you may not understand all of this on the slide, but I'm showing you all the code so that you can go and execute it. And by the time we come to the next class, you'll come back and tell me or send me email, hey, we finally understand how to implement this stack. In the process, actually, you're also implementing a linked list. So you will get your, as they say in India, your fundas would get cleared, Okay, so insert data. So when you're inserting data, you need to pass stack top. Whether you need a pointer to pointer, I did not verify that. Check that. I think it's a pointer to a pointer. If you have learned what pointer to a pointer is in C, that will be good. If not, this is your opportunity to test it out. Okay? You can draw it pictorially also and see what it is doing. And if you don't understand pointer to a pointer, remind me next class. I'll show you some examples of where that is used and how that looks conceptually. Okay, so you have some big for loop here. Node count equal to 0, node count less than 10. So it's creating some kind of a fixed structure here the moment it be hard-coded thing here, right? And then you are inserting characters. Basically, what he's inserting in that stack is a whole bunch of characters. Okay? A, B, C, D, E, F, and things like that. Okay? That is what insert data is. Now you are pushing it in the stack. Okay? So similar concepts here again. How do you push? You need to have a stack node be new. You are always returning success or failure. That's why you have this variable. Okay? And you can see line number 15 here. This is your first instance that you have seen where we got allocation for the stack node. And how does the compiler or the runtime system know how much to allocate space? It knows it is a type stack node where it has those two variables declared in the struct, right? So based on that, it knows how much memory it needs to allocate, and it's going to send whether it's a success or a failure, and that value is saved in new. So first you have to check whenever you're doing a malloc, remember that. Your C programming instructor would have told you that. Whenever you're doing a malloc, never simply say malloc and assume the memory has been allocated. You always say, hey, this new statement. And then you check whether new is null or not. Okay? If new is null, that means memory allocation has failed. So you will ensure that it's not failed. Then you come into the else loop here, line 18 through 23, where you remember you have to put the data, you have to change the link. Same thing. Whatever I showed you pictorially is what I'm doing programmatically here. Change the link, change the value of the top. And tell the calling program, hey, it has been successful. Success equal to true. Okay? Okay. Let me stop here, or let me see. There's one more piece of work. Similar print stack is pretty straightforward. You can easily handle that. Okay. Similar thing. I gave you a piece of code for pop. Okay. You can convince yourself that the code works. If you look at the statements here, when you are popping 17, 18, 19, 20, and 21. When you are popping, after the conditions are met, success is true. You are popping out wherever the pointer is pointing the top of the data. And then you're deleting that top. Now the top will point to the next element. Now whenever you're removing a node, you always want to free that node. That's what line 21 is. Because earlier whatever stack top was, you're saving that in p delete, and then you're telling the system, hey, I don't need that stack top node any longer. Take that memory away. That's what this line 21 is. Okay? Now, I do not know, honestly, what is your expertise in C programming. Okay? But the moment you get into stacks and queues, you better become good in programming. I can tell you that. You should at least be, on a scale of 1 to 10, your programming proficiency should be about, I would say, 6. 5 is bare minimum. You can get by talking to your friend and asking him to help you, him or her, giving him lunch. 6 is better, 7, 8, 9, and 10 are better. Much, much better. Okay? Believe me, even if I have to write this piece of code, sitting at my laptop now, I'll probably take 2 to 3 hours to write this code. Okay? I used to write a lot of code in my life, multi-threaded code I used to write, okay? A lot of parallel programming code also I used to write. But now, even for the simple stacking, even if I sit, in spite of my experience, it will still take me 2 to 3 hours to write this code. Okay? Programming is never easy. It takes a lot of time and persistence to do it. But once you have the fundamental principles, that is where the algorithm is coming into play, right? Before I showed you the code, I showed you the algorithm. And I showed you pictures of how these things flow when I use this linked list data structure. So those things will already tell me what kind of variables I need to declare, what is the order in which I need to perform the operations. If you look at the statements 17 to 20, that's exactly what I'm doing based on the algorithm that I showed you. Okay? Okay. I will stop here. Questions, comments? I know I went about 4 minutes over the time limit, but more. So what I will do next steps, I'm going to post this in the community after the class. I want you to review how the stack has been implemented using a linked list, and I want you to work in pairs, not alone. Work in teams of 2. Try to reproduce this programming code. I'm not guaranteeing all that code is 100% accurate, okay? But it's a good basis. Execute that code on at least creating a stack, inserting some elements, that is push, and popping elements. If you can do that and put it in the community saying, hey, I was able to do that and the program works, then I would know that you are able to do this stuff. I have 260 people enrolled in the community. I didn't check today. I expect at least a couple of pairs of 2, meaning that's 130, right? I expect about 100 answers in the community by the time we have our next class. Okay, go to the lab and do it. Questions, comments? Faculty members, please help me in terms of ensuring that these guys get some time in the lab to execute these things. Okay. Any questions, comments? I'm all yours now for the next 15 minutes if any questions and comments are there. I'm going to post this in the community right now. You can watch me post it in the community if you want to. If you have any questions, put them in the chat. I'll be happy to answer them for you. My system is a little bit slow here. The class is officially over, but I'll just hang in there. If you have any questions, I'll be happy to answer them. Put them in the chat.